Hi dear students, until last class we were discussing mainly the structural isomerism. In that we have discussed the first one, that is a chain isomerism. There we have seen that the principal carbon chain will change when chain isomerism is there, thereby the structure changes. Then the next one we discussed was position isomerism. So under position isomerism we have seen that the position of the functional group can change, the position of the substituent can change, or even the position of the double bond or triple bond can change. Okay, but there the number of carbon atoms in the principal carbon chain will remain the same. That is called position isomerism. Now we are going to see next one, what is called the ring chain isomerism. It is a kind of, I can say it is a kind of functional isomerism. Okay, it is a kind of functional group isomerism. It is a kind of functional isomerism. Okay, I will explain what is functional isomers. Okay, it is a kind of functional isomerism. Now here what is the basic difference? Here also if you take two compounds, the molecular formula or the molecular weight will still remain the same, but they differ in the linking of the carbon chain. That means here one compound will be linked in an open chain fashion and the other will be linked in a closed chain fashion. Then we say these two are called ring chain isomers. For example, I can say if you take the molecular formula C3H6, okay, I can represent this as CH3 CH double bond CH2. Now if you see this, carbon, 3 carbon atoms are there, 1 2 3, hydrogen atom 3 plus 1 4, 4 plus 2 6 are there. Now the same thing can also be drawn like this. Suppose somebody is drawing like this, CH2 CH2 CH2. Suppose somebody is drawing like this. Now if you see here also 3 carbon atoms are there and hydrogen atom 2 plus 2 4, 4 plus 2 6. So both are, if you see, they are one is a ring and the carbon atoms are linked through a ring structure and other is linked openly. So these two, if they are telling the compound 1 and compound 2, how they are related, we can say if in the options ring chain isomers are there, then we should surely say they are RCI, ring chain isomers. Suppose in the options there is no ring chain isomers are not present. In that case, we know that one is an alkene, correct? Other is an cycloalkane. So one is a cycloalkane and another is an alkene. So we can say they are also a kind of functional group isomers. But please believe that in the options, if ring chain isomerism is present, then the priority should be given to ring chain isomerism, because ring chain isomerism is a special kind of functional group isomerism. Okay. So I hope this is clear for you. If you have any doubt, let me know. Okay, so what we can conclude saying that, so we can say that, we can add one point here. We can say alkenes, we can add that point, alkenes and cycloalkanes are RCI, ring chain isomers. Okay, similarly we can say alkynes, okay, alkynes, and can you tell me with the alkanes who it will form? Cyclo. You can think like this, alkene coming with the cycloalkane, then alkyne will come with the cycloalkene. Okay, so alkynes and cycloalkenes are RCI, ring chain isomers. So these 2 points are very important. Okay, so as I told, ring chain isomerism is a special kind of functional group isomerism. So in the options, if ring chain isomerism is there, always you should go for ring chain isomerism if the two structures are given. But in the options, if it is not present, what you need to do? Then give priority to what? Functional group isomerism. So I hope it is clear for you. Next we will go to the topic functional isomerism. Okay. So next we are going to discuss what is called functional isomerism. So coming to the functional isomerism, here also we can say it is a subcategory under structural isomerism. Here the two compounds, they differ in the what? I can say the given compounds will differ in their functional group. will differ in their Fg, functional group. But they will still have the same molecular formula and the same molecular weight, but they will have different functional group attached. So similarly, we can say we can pair it actually. For example, first pairing will come here is alcohol and ethers. I have taught you earlier, both have the same general formula, but if you see in the structure, one will have the functional group OH and other will have the ether linkage O linkage. Let's see an example. For example, you have the alcohol CH3 CH2 OH. Now tell me, this is, you know what is this compound? Ethane-1-ol, correct? Ethane-1-ol. Now the same compound, if I write it like this, CH3OCH3. Now if you see here, both are having the same number of carbon atoms, 1, 2. This is also having 2 carbon atoms. Hydrogen 3 plus 2 5, 5 plus 1 6. Here also 3 plus 3 6. 1 oxygen atom, 1 oxygen atom. So both are having the same molecular formula. But if you see, one has the functional group OH and other has the functional group O. So what is the name of this compound? We can say its common name is dimethyl ether, correct? Or we can say even methoxymethane, that is the IUPAC name. Methoxy, we know, we use alkoxy as the naming for ethers. So we can say methoxymethane. So alcohols and others in exam, if they ask, they are what sort of, they will exhibit what sort of isomerism? I can say alcohols and others will exhibit functional isomerism. So similarly, we will see more examples. Next pairing is aldehydes and ketones. Okay. So aldehydes and ketones will also show functional isomerism. Aldehydes and ketones. Now how will you see this? We can take an example. We will take a simple aldehyde. We can take CH3 CH2 CHO. You can see the CHO group connected here in the case of an aldehyde. So what is the name of this compound? There in the principal carbon 3 carbon atoms are there. So we can say this is propan-1-ol. Correct? So the same, if you count here, how many carbon atoms are there? C3, 3 carbon atoms. Hydrogen 3 plus 2 5, 5 plus 1 6. So C3H6. And you can see 1 O is there. So this is the molecular formula. The same can be written as CH3 C double bond O CH3. Now please count the number of carbon atoms. Here also 3 carbon atoms are there. So C3, and number of hydrogen atoms means 6 are there and 1 oxygen. So C3H6O. So both are having the same molecular formula, but one, the functional group is a CHO and other have the functional group C double bond O, that is a ketone. So what is the name of this ketone? I know, if you number it, this is my principal carbon chain. So if I number it, 2 will come here. So the name of this compound is propan-2-on. This is propan-2-on and this is propan-1-ol. So I can say propan-2-on and propan-1-ol are functional group isomers or functional isomers. I hope it is clear for you. Now next we will see the third pairing. Okay, so there are a lot of pairs here. We need to learn that because in exam they may ask any of these. So you should be thorough with it. Now we see the third example where acids and esters. So acids and esters. So acids and esters are also functional isomers. So how will you see this? We can see, take one example here. So simple example here is a carboxylic acid CH3 C double bond OH. So you can see here COOH functional group is here. Now in esters, how I can write? So if I take an ester HCOO CH3. So if you see here, how many carbon atoms are there? 2 carbon atoms. Hydrogen, 4 hydrogen atoms are there. And oxygen, 2 oxygen atoms are there. Correct? Now if you see here, 2 carbon atoms are there. Hydrogen, 4 hydrogen atoms are there. Oxygen, 2 are there. So both are having the same molecular formula, but one is an ester, R, HCOOR. COOR is the functional group of esters, COOR. correct, and COOH is the functional group of acids. So I can still say these two are acids and esters are functional group isomers. Okay, now let's see the next pair. So if you go to the next pair, we can say cyanides and isocyanides. So A, B, C, D, fourth pair, cyanides and isocyanides. Okay, so cyanide, what is the functional group here? Cn, and isocyanide means Nc, correct? Nc. So cyanides and isocyanides are functional group isomers. We will see an example, CH3, CH2, Cn. Now count the carbon atom, 3 carbon atoms, so C3, hydrogen atom, H5N, correct? Now coming to the isocyanide, we can say CH3, CH2, Nc. Now again, if you count the carbon atom, it will be 3, hydrogen atom, it will be 5, correct, and 1 nitrogen atom. So both are having the same molecular formula, but they are having different functional group. This is having cyanide group and this is having isocyanide group. So we can say that cyanides and isocyanides are functional group isomers. I hope it is clear for you. Now we'll go to the next pairing. Okay, I hope all of you are note downing it. Please write down the notes in a regular way so that you can make use of it in the last NEET exam. So next one we say nitro and nitrite. Nitro and nitrite. Okay, so this is the fifth pairing, nitro and nitrite. Example, we can say CH3, CH2, NO2. Okay, so if you count here, 2 carbon atoms, C2, then hydrogen 5, then nitrogen 1 and oxygen 2. Now the nitrite means here the linkage is through nitrogen. Nitrogen is linked to the carbon, but in nitrite the linkage is different. CH3, CH2, O, N double bond O. This is called a nitrite, where the linkage is through oxygen atom. So please remember, if it is nitrite, the linkage is through oxygen atom, and if it is nitro, means the linkage is through nitrogen atom. And here also, if you see the formula, 2 carbon atoms, hydrogen 5 and 1 nitrogen and 2 oxygen. Again it is remaining the same. So nitro and nitrite are examples of what? Functional group isomers. I hope this is also clear for you. Now we'll go to the next pairing. So that's why I told there are a lot of examples under this category. That's very important also for exam. Okay. Now next very important thing is sixth pairing. So we can say 1 degree, 2 degree and 3 degree amines. 1 degree, 2 degree, 3 degree amines are examples of functional group isomers. Let's see by example. Let me draw 1 degree amine. CH3, CH2, okay, CH3, CH2, CH2, NH2. So if NH2 is present, that represents 1 degree amine. NH2 indicates 1 degree. Now how many carbon atoms? 3 carbon atoms, hydrogen. So you can say 3 plus 2, 5, 5 plus 2, 7, 7 plus 2, 9, hydrogen 9. Then we can say 1 nitrogen. So C3H9N. Now we will go for, this is a 1 degree amine. Okay, I will put it 1 degree here. Now we will go to the 2 degree. CH3. Okay. CH3. Then we say NH. CH3, NH, CH2, CH3. Okay. Now you can count here. Here also you can see the functional group becomes NH here. NH indicates 2 degree amine. NH2 indicates 1 degree amine. So here if you see 3 carbon atoms are there, correct? C3, hydrogen 3 plus 3, 6, 8 plus 1, 9, C3H9, then comes 1 nitrogen atom, N. So here also same molecular formula, but this is a 2 degree amine. Clear? Now we will try to draw 3 degree amines also. How we can draw that? Okay, that is little space. I will draw here. CH3, N, CH3, here CH3. Now if you see here, nitrogen, only if nitrogen is present, it indicates a 3-degree amine. Now carbon atom again C3H9, correct, and 1N. So this is a 3-degree amine. So what does this mean? All 1 degree, 2 degree, 3 degree, all are having the same molecular formula C3H9N, but they are having different structures through different functional group. Since it is having different structures through different functional group, we say functional isomers is a subcategory of structural isomerism. Clear? So all are having different functional groups. I hope this is clear for you. Now, can you tell me one compound, okay, one class of compounds which does not show functional group isomerism? Very, very, very important. You can expect this for NEET exam also. We can say alkyl halides, very important. So I will write it in red in color. Alkyl halides. Alkyl halides means what actually? For example, I can say C2H5Cl. One hydrogen is removed and a halogen is introduced. Any alkyl halide. So alkyl halides will not exhibit Fg, functional group isomerism. Very, very important. So with this I am just winding up the functional group isomerism. Next we will go to the topic metamerism. So next we are going to discuss what is called metamerism. So coming to metamerism, let me say metamerism is a special kind of position isomerism. So first point to be noted, that is it is a special type of position isomerism. Very, very important. So why I am saying this is, suppose in exam for a question given like this. Okay, let me first explain then what is metamerism, then I will go for that actually. Okay, so what is basically metamerism? So I can say that a metamerism is basically, okay, or if you say two compounds are metamers, I can say they will have the same molecular formula as like any other thing, same molecular formula, but what will differ? We can say they have the same polyvalent functional group. They will have the same polyvalent functional group, polyvalent Fg, but different alkyl groups, okay, but they have the different alkyl groups attached to the polyvalent Fg. So here basically I know that students does not know what is a polyvalent functional group. I will explain what it is. Let's see here. You have a functional group like OH. Now tell me, OH has how many valencies? That means this OH can be connected to the system or another structure through only this valency, correct? So I can say OH is a monovalent functional group. What it is? It is a monovalent Fg. Okay. Now let me take another example. For example, ethers. So we know ethers, the functional group is O linkage. So here if you see ethers, you have one valency here, another valency here. So this is connected to the system through these two valencies. So I can say this is a bivalent functional group, or we can say whatever that is not monovalent, we say that as what? Polyvalent. So this is a case of polyvalent functional group, polyvalent Fg. Fg means functional group. Okay, now can you categorize? I will give you some of the functional groups. Can you tell me what sort of functional group it is? For example, let me say carbonyl group, C double bond O. Can you say whether it is polyvalent or monovalent? Now you know that since it can be connected to the system through two valency, though this comes under polyvalent Fg. Okay. Now if you give you some other compound, for example COOH, carboxylic acid, you know that it can be connected only through this valency. So this is a monovalent Fg. Correct? This is a monovalent Fg. So I hope you understood what is the difference between a polyvalent Fg and a monovalent Fg. Now let me give you a list of polyvalent functional groups. You can note down. Okay, so let me rub this point. Okay, so the list of polyvalent functional group you can note down. Very, very important. Whenever this polyvalent functional group is there, you should always consider there is a chance of what? Metamerism is there. So let's say this is ether linkage is a polyvalent sulfo linkage, but this functional group is not present in your syllabus. This one, carbonyl group, it is a polyvalent functional group. Then we can say any derivative of acid, H is replaced by anybody else, COOR, ester, all these are polyvalent. And amide, CONH2, one H is replaced by somebody else, so this can be attached through this one and this one. So this is a polyvalent functional group. And secondary amine, NH, so this can be attached through any of this, so it is a polyvalent functional group. And tertiary amine having 3 valency, so more than 1, so it's a polyvalent functional group. And we can say anhydride, C double bond O, here C double bond O, so this can be attached through these two, so this is a polyvalent functional group. And like this you can note down all these are examples of polyvalent functional group. These are all polyvalent Fg. Okay, so let me say, now you know that this is a polyvalent Fg. Now the question here is, to this polyvalent Fg I can attach an alkyl group here, another alkyl group here. So what is metamerism means? Metamerism means if you are taking two ketones, it will have different distribution of alkyl group from on right hand side, and the same will differ on the other compound on the RHS. For example, I will give you an example, then it becomes very clear for you. Okay, let me take an example here. Okay, suppose you have a compound like this, example 1, very, very important, CH3O, listen, CH2, 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 CH3. This is the first compound that is given to you. And the next compound given to here is CH3O, CH, CH3, CH3. Okay, they are asking you what is the relation between 1 and 2. I can say here, first thing to check here is whether polyvalent functional group is here. Yes, it is present. Okay, so if you see here, polyvalent functional group is present here, correct? Here also. Now to the left side of that, a alkyl group CH3 is connected. Now the next one also I am looking here, also polyvalent functional group is there. To the left side of that, CH3 group is there. But on the right hand side you have a propyl group is connected, 3 carbon propyl, but here you can say an isopropyl group is connected. So they are differing in what? They have the same polyvalent functional group, but they differ in the alkyl chain. So one is having a propyl and other is having an isopropyl. So if they are differing like this, we can say these two are 1 and 2 are metamers. We can say they are metamers. Understood? Or they will exhibit metamerism. Now let me take another example, then you will get a more clear picture. Okay, so let's say the next example is this one, example 2. You have CH3, okay, CH2, C double bond O, CH2, CH3. This is the first compound given, and the next compound given here is CH3, C double bond O, CH2, CH2, CH3. This is the next compound given. Now they are asking you what is the relation between 1 and 2. So let me analyze. Since carbonyl group is present, it is a polyvalent functional group. Let's say this is polyvalent connected to 2 alkyl chain. This is also polyvalent connected to 2 alkyl chain. So to the one part LHS of the chain, we have ethyl group is connected and here methyl group. So it is different. Now here ethyl group is connected and here propyl group is connected. So these two are also different. That means to the same polyvalent functional group, different alkyl groups are attached, but both are having the same molecular formula. 1, 2, 3, 4, 5. So C5, hydrogen 3 plus 2, 5, 5 plus 2, 7, 7 plus 3, 10, 7, 10 and 1 oxygen. And here also you can see 1, 2, 3, 4, 5, C5. Hydrogen 3 plus 2, 5 plus 2, 7 plus 3, 10. C5H10 and oxygen is present. Correct? So both are having the same molecular formula, but to the same polyvalent functional group, different alkyl groups are attached. And you can now ask me, sir, why did you say it is a kind of position isomerism? I will explain now. Now, if you name this compound, what is the name of this compound? 1, 2, 3, 4, 5. So I can say the name of this compound is pentane 3-on. Correct? Now if I look at this compound, can you tell me the name of this compound? So this is my principal carbon chain. So I should start numbering from here because this will give the least number to the functional group. 3, 4, 5. So tell me the name of this compound. Pentane 2-on. Yeah. Now if you see here, the position of the functional group got changed. Here it was 3, here it was 2. So that means if the position is changed, it should be what actually, and the principal carbon chain remains the same. So we can say it is also a kind of position isomerism. So that means in your question, suppose the same question is given and they are asking you the options, different options. If metamerism is there, the priority should be given to metamerism. But if metamerism is not present, then the priority, then the next option should be, you should check whether position isomerism is there. Then we can say it is position isomers. Okay, I hope you understood the example. Now, I can give you more examples. One more example I can give you. Listen. Example 3. Okay, so once you see more examples, it becomes thorough in your mind. So example 3, let me draw. Example 3, CH3 NH. Okay, CH3NH, CH2, 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 CH3. Okay, so what is the molecular formula? 1, 2, 3, 4, 5. Carbon 5. 3 plus 2, 5, 5 plus 2, 7, 7 plus 2, 9, 9 plus 3, 12. C5H12. So 3 plus 2, 5 plus 2, 7 plus 2, 9 plus 3, 12 plus 1. 13 is there. Okay, and 1 nitrogen atom is there. Now the same can be written like this, like also CH3 NH CH2 CH CH3 CH3. Now if I look into this compound, here also you can see the same thing. How many carbon atoms are there? 1, 2, 3, 4, 5. 5 carbon atoms. Hydrogen 3 plus 1 4, 4 plus 2 6, 6 plus 3 9, plus 1 10, 13. H13 and 1 nitrogen. So if you see here, you have the polyvalent functional group. Into this polyvalent functional group, different alkyl chain is attached. Here a linear chain is attached, and here you can see a branched chain is being attached. So both are differing in the alkyl chain part that is attached to the polyvalent functional group. So these two are examples of what actually we can say these are examples of metamers. I hope now metamerism is almost clear for you. Now we will go to the next type of structural isomerism, that is called tautomerism. What it is called? Tautomerism, or the other name of tautomerism is desmotropism. Desmotropism. Okay, now we will start what is called tautomerism or desmotropism. Before coming to that, I thought of giving you one question like thing. You can just see here CH3 C double bond O C6H5. Okay, other one is C6H5 C double bond O CH3. Can you tell me how compound 1 and compound 2 are related. What sort of isomers are they? Now you can see here again the same case. This is a linkage, COO linkage, correct? Polyvalent function group. Now here if you see C6H5 is connected and here CH3 is connected, so they are differing in the alkyl part. Here CH3 is connected and here C6H5 is connected. And many students will ask a doubt here, sir, we can rotate this so that both will become same. No. Why? Because here C6H5 is connected to O linkage. It is connected to O linkage. Here C6H5 is connected to C linkage. So if you make it rotate also, how rotation means what actually? So I will write CH3 here, O here, C double bond O, here C6H5. So can I say the compound 1 and 3 are similar? Many students will say, so here CH3, here CH3, here C6H5, here C6H5, here COO, here COO. So both are similar. Wrong. Very, very important. They will ask in exam. Please understand, here carbon atom is linked to another carbon atom. Carbon-carbon linking. Here C6H5 carbon is linked to oxygen atom. And here CH3 carbon is linked to carbon atom. Here CH3 carbon is linked to oxygen atom. So both are different. So these two, 1 and 2 are metamers. Understood? Very, very important example they used to ask for exams. In options they will give metamers, they will give functional group isomers, and option C identical, and option D none of these. So most of the students will give identical, thinking like both are similar, they have just rotated it. But please see the linkage. Linkage is very important. If linkage is same, we can say it is identical. Okay, I will give you another example for that, just to see this. So I hope you have noted down this. Very, very, very important. So next one, listen here. You have suppose given question like this. Okay, HCOO CH3. Okay, so that means you can see here it is an ester, HCOOR, and they have given you like this, CH3 C double bond O H. So here also you can apply the same concept. If you see here whether both are identical or not, how you see this? You can divide like this and see here H is connected with the O linkage, here C is connected with the C linkage, here O is connected with the CH3 linkage and H is connected to C linkage. Again both are what actually? Metamers. So this is a one time asked question for AIMS. So please understand that both are not identical. Okay. I hope it is clear for you. Now we will go to what is called the desmotropism or tautomerism. Okay, so I can give the heading tautomerism. Very, very important. You can see every question paper or every previous questions, there will be one question from tautomerism. So tautomerism, it is also called desmotropism. So who introduced tautomerism? The tautomerism, what does it mean actually? This means bond turning. Bond is rotating or turning. You can say turning, that is more correct. This means bond turning. And this was introduced by a scientist called Lahr. Who is this? Lahr is the scientist who introduced the concept of tautomerism. Now we can say here also, if you say two compounds are tautomers, if two compounds are tautomers, they will have the same molecular formula. They will have the same molecular formula. Okay, they will have the same molecular formula. And what will happen? However, they have different structural, but they have different structures. How these different structures are happening? But they have different structures due to the wandering nature of acidic hydrogen atom. Please note down this. So I will explain which is the acidic hydrogen atom, why it is wandering, all these things I will explain. Okay, acidic hydrogen atom between the two atoms. Okay, so this is you need to note down. Now let's see an example to explain what a tautomerism is. Okay, I hope you have noted down this. Now let's see an example. Okay, so let's say here you have a compound like this, CH3, okay, C double bond O H. Now what is acidic hydrogen? That is what I am going to say. I can say, to understand that, please listen to this first. You have a functional group CHO here, okay. The carbon atom which is connected to the functional group is called my alpha carbon atom. Please understand, I am using first time the term alpha carbon. Please understand, the alpha carbon atom is which one? The carbon atom which is connected to the functional group is called my alpha carbon atom. And the hydrogen atom attached to the alpha carbon is called alpha hydrogen. Writing down here, hydrogen, okay, attached to hydrogen, attached to alpha carbon atom is called what actually? Alpha hydrogen. So they are telling like this hydrogen atom is acidic in nature. The hydrogen atom which is attached to alpha carbon atom or alpha hydrogen is acidic. Now let's see why they say it is acidic. Okay, to understand that I should say what is acidity or those things. Already we are going to explain that in the coming sessions, but I will explain now also. Listen here. Now you can say if a compound, for example, let's say I will say an example like water. Okay, let me say water is the best example, H2O. If I am saying water is acidic, so what does that mean? Water should be capable of donating H plus. This is the fundamental definition. Then if it is donating H plus, what does it will become? It will become OH minus and H plus. If somebody is capable of donating the H plus, then we can say that as acidic in nature. Okay. Now let's see if H plus is whether everybody, those who are having if any compound which is having hydrogen atom, whether it is capable of donating H plus. This is the most important question. If you are able to predict that, then we can say whether the given compound is acidic or not. Please remember, for this the best thing to remember, I am giving a shortcut. You need to think like this. After donating the H plus, okay, after donating the H plus, the remaining structure is this one. After donating the H plus, if the remaining structure is stable, after donating the H plus, if the remaining structure is stable, then we can say this particular compound is a good acid. But if it is unstable, the remaining structure is unstable, then what it will do? It will never give the H plus, because after donating the H plus it is becoming unstable. Will you allow that? One simple example I can say. You think you have a great friend with you, okay, and suppose you were having initially a good amount of money and all with you. So when your friend asked you some amount of money, you have donated him. So you are able to donate. Why? Because after giving that money also, you are still having sufficient amount of money. That means you are stable. You can give. But think like after corona pandemic and everything, people lost a lot of money and everything. Now your same friend is asking you the same amount of money. Now you will think whether I can give it or not. Because if you give, you will become unstable. You need to ask someone else. That will you allow? Normally people will not allow, because you will become unstable. So think in the same way, if somebody is capable of donating the H plus, and after donating the H plus, if the remaining structure is a stable stuff, then you can say that is a good acid. Now the good question here is, sir, our stability we can check, but for a chemical compound, how can we measure the stability? This is why I told this topic comes next, because the stability of a compound is determined by inert rule, correct? You can see here OH minus, so minus charge is coming to oxygen atom. We already know oxygen has a tendency to attract the electrons to attain stability. So minus charge coming means electrons are coming, so it is becoming stable, I can say. And similarly we have different concepts. Resonance is there, hyperconjugation is there, inductive effect is there, all these, and electromeric effect is there. All these effect will determine the remaining structure is stable or not. That is the reason why I have told I will teach you the next topic in the next concept, that is all these effect. Then I will as an application of that I will teach you the concept of acidity and basicity. Okay, now for this topic, how will you learn that? I am going to explain that. Listen, now you have a compound like this, CH3 CHO. Now you want to check whether this is capable of donating H plus or not, or whether it is an acidic hydrogen or not. So let's say I am redrawing the structure like this, CH2H C double bond O H. Now you think like the same way what I have told. Suppose this alpha hydrogen is lost. Lost means donated. If it is donated as H plus means proton. Now you know that these two electrons will reside with the CH2. Then it will have the remaining structure like CH2 minus C double bond OH. Correct? Now I need to predict whether this structure is stable or not. Now I can easily say this is stable. Why? Because I already learned resonance somehow. You can think like minus charge, single bond, double bond. So there is a conjugation is there. So surely this minus charge in the next case it will form a double bond here. Then this will come over here. This will become minus here and H will come here. So this is the resonating structure of this one. So what does that mean? If you have resonance, why you are saying there is stability is there? Because in chemistry stable means you should be stable like this. Nobody should come and attack. Correct? Now here when minus charge is sitting at one place alone, then it has a higher probability that it may attacked by oppositely charged species. Correct? So that means if it is residing, minus charge is residing at one location, I can say it is almost unstable. But if you have resonance in that particular compound, what will happen? The attacking reagent, you can think like a positive charge is coming like this and it is trying to come and attack. But because of resonance, this guy will form a double bond here and this will form a minus charge here. Then the positive charge comes here, it is seeing like minus charge is in the oxygen atom. So that means the minus charge keeps on wandering. That means that compound becomes stable because no opposite charge is now coming and attacking. Now the opposite charge if comes and attacks here, immediately it will form the other structure. So indirectly it means that because of resonance, negative charge is not localized, it keeps on delocalizing. That will give a stable nature to this compound. So I can say this is a good acid because the remaining structure is stabilized through resonance. So simple concept is very simple, that is minus or plus charge if it is staying in a compound without any movement or with that magnitude, if it is staying like that, then it is unstable because it can be any time attacked by oppositely charged species. But if that negative or positive charge magnitude is either decreasing or it is wandering like this, we can say that compound is more stable because it cannot be attacked by the oppositely charged species. I hope you understood the concept. Now listen here, so in this case, if H plus is gone, this becomes CH2 minus C double bond of H. So in that way, we can say this hydrogen is what in nature? Acidic hydrogen, alpha hydrogen present over here is acidic. It does not mean that if you have some other functional group and when H plus is donated, it will become stable. No, you need to check, since CHO is there, this is having alternate or conjugation nature and it is becoming stable. Understood? So that is one important property of the functional group C double bond O. So whenever C double bond O functional group is there, near to that carbon, if any hydrogen is there, that is acidic in nature. Okay? And don't think this hydrogen is acidic, because if it is lost, this will become what charge? Minus. And if it is minus, then double bond. That is not possible. There should be conjugation. Minus, single bond, double bond. Okay? So I hope you got some rough idea. Okay? Now let's see how this tautomerism happens here. So let's explain how the tautomerism is happening. So I have just earlier told how that the concept of acidic hydrogen. So I can say here the same example I am taking, CH2, CH3, C double bond O H. As I told here, after donating one hydrogen, okay, let's say the acidic hydrogen is gone away since it is acidic in nature. So what will happen? So this will become, or this will be changing to, you can see here, CH2 minus C double bond O H. Correct? So what happened? One H plus has gone out. Now my question here is, as I told, this can exhibit resonating structure. Correct? So what will happen? The resonating structure of this one will be, the minus charge will move in this direction. So this will become CH2 double bond, and this will move in this way. So this becomes O minus and H. Now let's say at this point of time, this H plus is coming back. So H plus can either come and attack, there is a probability that this can come and attack this structure, or it can come and attack this structure. Correct? So if it is coming and attacking in the first way like this, it's coming and attacking, you will get your initial structure similar to this. I mean, this will be your first structure. Correct? And if the H plus is coming and attacking this structure, this resonating structure in the second way, then I can say you will get a new structure that is called CH2 double bond COH H. Now if I am looking at these two structures, if you see these two structures, this is a structure 2 that is obtained from second attack. That's why I am putting 2. If you see here, number of carbon atoms, 1, 2, 2 carbon atoms, so C2. And hydrogen atom, 2 plus 1, 3 plus 1, 4. So 4 hydrogen atoms. And there is 1 oxygen atom, so C2H4O. And here also 2 carbon atoms, C2, hydrogen atom 4, and 1 oxygen atom, C2H4O. Now if you look at these two structures, both are having the same molecular formula, but both are having different structures. Okay, so now you might have understood why these two structures have came up, because of the presence of what hydrogen? Because of the presence of alpha hydrogen or acidic hydrogen, which is moving out, and that is giving you a resonating structure that will giving you two structures. And here if you see, in this carbon atom itself, OH group, that is alcohol, and to the same carbon atom double bond is there. So we call this as enol. En for double bond and ol for functional group OH. So we call this as enol. Since here carbonyl group C double bond O is the present, here we say this as keto group. So we usually call this isomerism as, in another way we can say this is called keto enol tautomerism. Keto enol tautomerism. So if you have not understood, please revisit the video. I have told completely. Very simple. You have the structure, H plus is going out, you have a minus here, resonating structure I have drawn, and you can think like H plus is coming back. It may be the same H plus or different H plus. Now it has two possibilities. The first possibility, you will get back the same compound. Why? Because H plus is coming here, minus charge is here, attraction will go in this direction, and you will get the first compound. And if it is in the second possible way, second structure means the minus is present here, so it will come and attack here, and you will get the second structure. And 1 and 2, if I am looking, both are having the same molecular formula but different structures. One is called, since that to the same carbon atom double bond and function OH group is connected, we say en plus ol, we say enol, and this is called keto. So we say this isomerism, or if you have these compounds, we say keto enol tautomerism. So I will write two mandatory conditions for keto enol tautomerism. That is very, very important. So one is what, actually, you know, the presence of acidic hydrogen or alpha hydrogen atom. So let me write the two important conditions. The first one, the presence of alpha hydrogen atom or acidic hydrogen atom. And what is the next condition? The next condition is the carbon atom to which the alpha hydrogen atom alpha hydrogen atom connected the carbon atom to which the alpha hydrogen atom the carbon atom to which the alpha hydrogen connected should be sp3 hybridized. It should be sp3 hybridized. Very, very important. So these two conditions you can check, and with this you can check whether that compound will exhibit tautomerism or not. Let's see a lot of examples and confirm that we understood the concept of tautomerism. Say we will go with example 1. Okay, I hope you have noted down all these things, very, very important for exam. Okay, so coming to the example 1. So CH3 C double bond O H. Can you tell me whether this compound will exhibit keto-enol tautomerism? Okay, first criteria to be checked here is, now this is my alpha hydrogen atom, okay, that is connected to this carbon atom. What is its hybridization? How will you check? Here hydrogen, here hydrogen, here hydrogen, here C double bond O, here H. I know that this is S, this is P, this is P, this is P. So this is sp3. And there is, to this functional group, to the nearby carbon, there is hydrogen is also present. So presence of alpha hydrogen is there. How many alpha hydrogen? 3 alpha hydrogen is there, and the carbon atom is sp3. So I can say this will exhibit tautomerism. Understood? Now next example I will take. Okay. Now the next example is CH3 C double bond O CH3. Can you tell me whether this compound will exhibit tautomerism or not? Very simple. Take the functional group, keto group is connected into near, this is my alpha carbon, this is also my alpha carbon. So totally how many alpha hydrogens are there? 6 alpha hydrogens are available, and the hybridization of this is also sp3 and this is also sp3. So that means this compound will also exhibit tautomerism. Okay. Now let's see one important question. Then I hope then you will get a more clear picture. Okay. So let's say whether HCHO, okay, whether this compound will exhibit tautomerism or not. So many students will say, sir, hydrogen is present. Okay, so please understand, this hydrogen is not alpha hydrogen. Why? Because there is no alpha carbon. If there is no alpha carbon, there is no alpha hydrogen. So there is no alpha hydrogen since no alpha carbon. So this compound will not exhibit what? Tautomerism. This compound will not exhibit tautomerism. I hope you understood. Now let's take next example. Okay. I hope you are now getting the topic clearly. Now let's say this one is a good question. Okay. Okay. So this is given here. Now I know that this is my functional group CHO, correct, or CO functional group. Into this you have connected a carbon, so this is my carbon, and we know that one valency is going here, two valency is going here to another carbon. So there should be one hydrogen that must be pending, correct? But the problem here is, what is the hybridization of this carbon atom? This carbon atom, what is the hybridization? The hybridization of this is S, this is P, and if I am taking together this one, this is also P, that is this carbon atom is sp2 hybridized. So that means alpha carbon is sp2 hybridized. So this compound will not exhibit tautomerism. Understood? So the compound will not exhibit what? Tautomerism. Clear?